Alright, let's now discuss the back-of-words model for working with text data. So just as a brief recap, our workflow is still as follows. We start with the raw data, we pre-process the raw data, create these feature vectors, and then feed the feature vectors to the machine learning model. Now, the way we represent the feature vectors, that's where we use the back-of-words model. So let's discuss what this back-of-words model is and how it works. For this, let's use a simple example where we suppose we are building a classifier to identify funny sentences. So for this, we have an example training dataset where we have multiple sentences, and for each sentence we have a label whether it's funny or not. In the back-of-words approach, the first step is to extract all the unique words here from the training dataset to construct the so-called vocabulary. So the vocabulary then contains all the unique words that we encounter in the training dataset. And then in the second step, we take this vocabulary together with the training data to create these so-called back-of-words count vectors. So here we are transforming the text from a raw text or preprocessed text representation into vectors. And as you can see here on the right-hand side, this is essentially a tabular dataset. And the columns of this dataset, these are the individual words of the vocabulary. So in other words, the size of the vocabulary determines the number of columns here, the number of features. So then we take these input sentences to create the back-of-words vectors. So each back-of-words vector is essentially a count vector where we have zeros for words that are not contained in the sentence, and the count, for example, a 1, if the word occurs in that sentence. We repeat this procedure for each input sentence then to create this tabular dataset for machine learning. And yeah, then once we have this dataset, we can train our machine learning model. So as a side note here, before we refer to the back-of-words vectors as count vectors. However, I should mention there are also modified versions of these count vectors. For example, there's this n-gram model approach where before we used a 1-gram model where each individual word is one word in the vocabulary. However, we could also create these so-called 2 grams or bigrams where we have combinations of 2 words that form the vocabulary. It's just an alternative to the back-of-words approach that we took before, where we have now 2 words at a time. And then there's also this popular TFIDF approach, where TFIDF stands for term frequency inverse document frequency. So TFIDF refers to how often the word occurs, weighted by the number of documents it occurs in. So we can think of it like this. A high term frequency corresponds to how important the word is. And then when we have a high document frequency though, it might indicate that this word is not as important because it occurs in many different documents, so it's not very informative for distinguishing between documents. Okay, so in this video we briefly covered how we construct back-of-words models to train machine learning classifiers. In the next video, we will train our very own back-of-words based classifier to solidify these concepts.